All right, so I went ahead and started the live. Let's go ahead and get started with today's stuff. So we've pretty much gone through a lot of derivative rules. We've been doing derivatives for, well, pretty much a long time now, ever since we finished up limits. And we know we've gone beyond doing the limit definition, because for all of these larger functions, it would be terrible to force y'all to do a limit definition for something without those rules and stuff like that. All right, so now that we've pretty much covered all of the derivatives that we're going to learn, let's go ahead and list them out all together. So what is the very first derivative rule that we pretty much learned? Yeah, the first one was the power rule. So I'm going to go ahead and write power rule. And that said that the derivative of, let's say, x to the n power. What's the derivative of x to the n power? Yeah, n times x to the n minus 1 power. This was our first derivative rule and probably one of our most useful ones because we end up using it, well, all the time. All right, so we've got the power rule. Put a little dot there. Someone give me another rule that we've learned. Any of the rules, any order. Product. So product rule. So how would you describe the product rule? Yeah, product rule was first d second plus second d first. For the sake of just having it on here, I'm going to first write out the little formal way, and then I'll write it out the way that we always talk about it. That is, if I take the derivative of f times g, then I get the first derivative of the plus the second derivative of the first. Or as you see me write more frequently, first d second plus the second d first. Great. So I have my product rule. What's another rule that we can go ahead and talk about? Quotient rule. Move this over. So quotient. I don't know if the camera's going to be able to go up this high, but we have the quotient rule. So while I'm writing this, someone go ahead and tell me what is the quotient rule. You can use the phrase in terms of the lows and the highs. Yes. So we like to remember the quotient rule is low d high minus high d low all over low squared. So I'm going to write what y'all just told me, low d high minus the high d low all over low squared. Or if I'm writing it in terms of this f and g stuff, we have g f prime minus f g prime all over g squared. All right, so I have the quotient rule. Great. Give me another rule. Any of the rules or any specific derivatives. Natural log. We just did that one. Let's see. I have some room down here. So talking about the logarithm, logarithmic. In particular, if I want to be exact, technically we did the natural log, logarithmic function. So if I wanted the derivative of, let's say, the log of x. What's the derivative of the natural log of x? Yeah, 1 over x. All right, so we had the derivative of the natural log function. We still got plenty more. And go ahead. Chain rule. We definitely use chain rule a whole lot. Let's put this in black. Make that a little bit larger. So chain rule. And I'm not going to write this formal version out because we often use it in terms of let's go ahead and take the derivative of each layer. So I'm not going to write the formal way that we had it at the very beginning. Also, that way that we had it at the very beginning, it was more suited for only a 2-layered function. But we've done stuff that had like 3, 4, 5 layers. So that's why I'm not going ahead and actually writing out the chain rule as we know it, from the book at least. I've got plenty other derivatives. What else can I talk about? Yeah, so I heard 2 of them, one for trig and then one for the inverse trig. So at this point, I'm just going to go ahead and list these out, trig, and then the inverse trigonometric functions. Trigonometric. Trigonometric, and then the inverse trigonometric functions. All right, so let's go ahead and start with the trig functions. I'm not going to write them down because there's so many. It would take a lot of space. Let's go ahead and for the trig function, let's start with derivative of sine. So the derivative of sine was what? Yes, cosine of x. Derivative of cosine. Yeah, negative sine of x. Mixing up the order, let's take the derivative of cosecant of x. Yes, so the derivative of cosecant of x should be negative cosecant of x, cotangent of x. We gotta be careful about which one's got the negative and the positives. Okay, so just bouncing off of that, what's the derivative of secant of x then? Secant cotangent? Yeah, secant x tangent of x. Because remember, we the derivatives had this little nice property where I had the 3 on the left, the 3 on the right. To go from the left to the right, it looks like I took the co-function and made it negative. Let's have 2 more trig functions. Let's start off with derivative of tangent of x. What was that? Yeah, so the derivative of tangent was secant squared of x. And then the last trig function, derivative of cotangent of x. Not secant times tangent, because we know the derivative of secant was secant x tangent x. Well, y'all just told me that the derivative of, we just did tangent, right? Y'all told me that that's secant squared of x. Not the square root if I want the derivative of cotangent of x. Well, let's see. I have tangent and then its co-function, cotangent. In other words, these were in the same row whenever I gave you those 6. Negative, yeah, first off, it is going to be negative, cosecant squared of x. So we had this nice property between the co-functions. We saw that with sine and cosine, right? Derivative of sine is cosine. Derivative of cosine is negative. Yeah, sorry, had something metric. Derivative of cosine, negative sine. So yeah, this is what I was saying before, where if you know the 3 on the left, you can just translate them over to the 3 on the right. All right, so I've got the trig functions. Now let's go for a little bit tougher ones, the inverse trigonometric functions. I'm going to go ahead and ask for, let's start it off with the first one, arc sine of x. What's the derivative of arc sine, or you can say sine inverse of x? One over the square root of 1 minus x squared. Let me clean up that little 2 here. There we go. 1 over the square root of 1 minus x squared. Are we all in agreement that this is the derivative of arc sine? All right, so I have arc sine. What's the derivative of arc cosine? Yeah, the negative version of that, basically, a negative one on top. Again, we had that same property with the cofunctions. It's not really exactly the right term, but the inverse cofunctions. What about, let's do arctangent of x. Yeah, so derivative of arctangent of x was 1 on top, divided by x squared plus 1, or you say 1 plus x squared, doesn't really matter. So what I was saying here was 1 over 1 plus x squared, for example. And then you can probably guess the derivative of arc cotangent is the same thing but negative, because it's the cofunction. All right, and then we had our last two, arcsecant, or secant inverse of x. What is the derivative of secant inverse of x? This one's the longer one of the group. So we have 1 on top for sure. Let me just write it right here. For arcsecant, we have 1 on top. What else do I have on the bottom for arcsecant? Just anything on the bottom. So we have something that looks like this for arcsecant's derivative. 1 over the absolute value of x times the square root of x squared minus 1. One thing that we always need to be careful about is that we saw here, this was for arcsine, this was for arcsecant. We gotta make sure, is it 1 minus x squared or x squared minus 1? Because those are different values. They're the negative versions of each other. And then I'm not gonna bother for arc cosecant, because it'll be this, but with a negative 1 on top. All right, great. So we've done the inverse trigonometric functions. Have we done any other derivatives? Yeah, we did exponential. Exponential, which told me that the derivative, I can fit it down here, of e to the x is what? Yes. Our sole derivative, that's the only function where the derivative is itself. All right, so sounds great. So I believe this, if I'm not forgetting any, this covers generally all of our base derivative rules. What other concepts did we talk about through this chapter as well? That wasn't necessarily a derivative rule per se. We learned properties of the log function. And with that, we also learned about this logarithmic differentiation, where I take the logarithm of the left and the right, and then take the derivative from there. So that's what we covered most recently. What else was a really big thing that we talked about outside of just saying the derivative of this is this? I'm thinking about one that starts with an I. Yeah, implicit differentiation. And what was a big difference between something that was explicit versus implicit form? More or less, yeah. So we have the explicit meant I always had some, for example, y is equal to whatever x is, and then I can take the derivative normally, quote unquote normally. Implicit form generally meant that I don't necessarily have a single variable by itself and then all of the rest of my equation or function. And so whenever I had something in an implicit form, I was able to do my implicit differentiation, which was just a fancier way of me saying I take the derivative of both sides, keeping in mind my dy dx's and stuff like that. All right, so these are all of the derivative rules off the top of my head that I believe that we covered pretty much through this entire unit. So with that, let's go ahead and talk about our exam number 2. So when did I say to plan for our exam number 2? Tuesday. So now that's 6 days from now, basically. Um, so with that, let's go ahead and do some discussion here. I'm going to go ahead and pause this live recording here because that's not really going to be relevant for everyone.